Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Ningtias.P.Putri bersama rekan saya yang bernama Isradel O.Kambu. Di sini kami akan membahas tentang smart smoke detector. Tingkat atau bangunan megah lainnya, khususnya di perkantoran, di wilayah-wilayah luas itu sangat berkembang pesat pembangunannya, baik itu milik perusahaan maupun perorangan. Di dalam sebuah bangunan tentu memiliki jumlah penghuni yang berbeda-beda. Oleh karena itu, keselamatan diri setiap penghuni di dalam sebuah bangunan harus diutamakan. Salah satu yang menjamin aspek keselamatan dan keamanan gedung adalah tersedianya sistem peringatan dini terhadap bahaya atau bencana yang dinamakan smart smoke detector atau dalam bahasa Indonesianya sering disebut detektor asap. Alat ini sejenis sensor yang dapat mendeteksi adanya segumpulan asap di dalam sebuah ruangan. Ada 3 jenis smart smoke detector. Pertama adalah detektor asap fotolistrik. Detektor asap fotolistrik adalah jenis smoke detector yang menggunakan cahaya yang mendeteksi adanya gumpalan asap. Sinar cahaya yang berbentuk denyutan dari lampu LED dengan optiknya yang akan dipancarkan garis lurus ke bagian tertentu pada chamber atau ruang hitam yang terdapat di perangkat detektor. Sebuah sensor foto yang juga dilengkapi lensa optik diletakkan di posisi bagian bawah dasar vertikal. Sensor foto ini akan menghasilkan arus apabila terkena cahaya. Pada saat tidak ada asap, sinar cahaya LED akan menembak secara garis lurus dan tidak akan menyinari sensor foto yang terletak di bawah sinar tersebut. Namun, apabila terjadi kebakaran dan asapnya memasuki ruang atau chamber detektor, maka cahaya akan berbelok dan diarahkan ke sensor foto sehingga mengaktifkan sinyal alarm. Kedua adalah detektor asap ionisasi. Cara kerja detektor ini adalah apabila terdapat sejumlah partikel akibat kebakaran yang memasuki chamber atau ruang hitam, partikel-partikel tersebut akan mengganggu gerakan ion biasa atau ion normal sehingga arus turun menjadi lebih rendah, maka sinyal alarm akan segera diaktifkan.
Di sini saya akan menjelaskan bagian yang ketiga, yaitu project smoke detector. Project smoke detector bekerja berdasarkan prinsip pengaburan cahaya yang terdiri dari sebuah lensa pemancar, penerima cahaya receiver, dan reflektor. Cahaya pada kondisi normal, pemancar cahaya memancarkan sinar cahaya tidak terlihat dan diterima oleh penerima receiver. Penerima atau receiver dikalibrasi pada tingkat kepekaan tertentu berdasarkan presentasi dari seluruh kondisi pengaburan. Ketika ada asap yang mengaburkan sinar, sinyal alarm akan diaktifkan project beam smoke detector. Saya akan menjelaskan prinsip atau cara kerjanya smart smoke. Alat-alat pengindra yang memiliki komponen. Yang pertama, ruang deteksi yang dilengkapi dengan pemancar cahaya inframerah. Yang kedua, penerima cahaya inframerah. Yang ketiga, rangkaian elektronik kontak. Di sini memiliki prinsip kerja. Bekerja dengan menggunakan ruang sensor cahaya bila terjadi kebakaran. Saat asap memasuki ruang sensor, maka asap akan memutuskan garis cahaya laser dan memicu alarm untuk bekerja. Smoke detector jenis ini bekerja dengan baik sehingga kebakaran merambat dengan lambat dan akan mendeteksi sebuah asap.
New lab is ready.
new lab is in a separate building, so I want a solution that notifies me if something is going on there, especially if it's a fire. I bought this cheap smoke detector. The most smoke detectors have some kind of interface which can be used to read out externally. This one doesn't have a connector, but it seems that there are at least some pads. I opened it, scraped off the protective coating and soldered on some pins. By pressing the test button of the detector, I was able to find the pins which had a high signal when beeping and low when inactive. If your detector does not have any pins, you could also hook the beeper connections directly. I designed a circuit that enables the power to a Wemos microcontroller whenever the smoke detector is set off. I also added a possibility for the controller to disable the power again using pin D1. And also connected the detector signal to pin D2 to measure if it's beeping repeatedly. Essential for this circuit is to protect it on the input side from overvoltage by a Zener diode and to use MOSFETs with a low source gate threshold voltage but a high enough current rating. 2N7000A worked for me. The complete circuit is powered from a small lithium polymer battery with a high voltage of 4.2 volts. This helps to reach the source gate threshold. Thankfully the ESP is very forgiving and even kind of 5 volt tolerant on the input pins. Since I feed the 4.2 volts on the 3.3 volt power lane, it would probably overheat after some time. But this circuit is only powered on rare occasions, so it's good enough. As a next step, I soldered a more convenient JST connector to the smoke detector and transferred the breadboard circuit to a Wemos Shield perf board. For the software part, I have tried Mongoose OS for the first time. I really love it since it is easy to set up. First of all, you have to connect your Wemos via USB. If you are doing this for the first time, you can download the serial drivers from the homepage and also find some GPIO pin mappings, which is handy when using on Mongoose OS since it's working with GPIO pin numbers, not the actual Wemos labels. To be able to use Mongoose OS, you download the tool from the website and start it. It might warn you that the software is not secure since it's not signed, but you can bypass this. The tool starts a local web server and opens a web page. There you find a simple setup where you select the serial port which is shown after you connect your Wemos via USB. Then you can upload the bootloader. If you have a pesky sketch on the Wemos running which prevents you from flashing the bootloader, you can keep the reset button pressed until you see in the log when the flashing process is started. If the tool even fails to connect to the serial port, you might even try to reconnect the USB while keeping the reset pressed already. After entering your Wi-Fi credentials, you can start to code. There are many things to explore on Mongoose OS. For this project, the init.js, which runs on startup, is the only important file. You can replace the contents with my code. There is only one thing to do in the code. You have to enter two links which will be called when either smoke is detected or the smoke detector battery is low. Now let's generate those links. I am using if this then that. You can create an account for free. If you don't know this tool yet, it simply provides an interface for triggers and actions. In my case, I want to be notified via SMS when my lab is on fire and get a simple notification when the battery is low. As a trigger, I want to use a simple web link. If this then that provides a maker service which allows the usage of simple web links as triggers. You have to add this service first. Then also add the SMS service and verify your phone number. Now you can create your applet with the trigger maker webhook. the keyword will be smoke. The action taken will be an SMS with a specific text. I also add an applet for the message for low battery. The app notification on my phone will be sufficient for that, but this only works if you have the app installed. Now we are almost finished here. To get the link we need for the Wemos detector code, we have to go to Services, the Maker webhook and then Settings. There is your personal and secret link displayed. Only share it if you want other people to be able to trigger your applets. You can get a new link by pressing Edit Connection. The old link will become invalid, so be careful or your smoke detector will not be able to warn you. And then take the link and open it in the browser. It is better, but it's not needed to use HTTPS. You can enter your keyword here. Smoke in my case. Then copy the link and paste it in the code of the microcontroller. When you have finished pasting the links, simply save and reboot. The SMS service is limited to 100 SMS per month inside and only 10 SMS outside the US. After the limit is reached, you will not be notified anymore. You might want to use additional applets or actions to be on the safe side there. I also designed and printed a small case for the circuit, but this is optional. Don't place anything bulky inside the smoke detector, otherwise the smoke will not reach the sensor. Time to test it! The code checks after 1 second if the detector is still beeping. If not, it probably beeped once to notify of a low battery power. If it's still beeping, it detects smoke. After it called successfully the link you provided for the needed action, it turns off again. By pressing on the detector button, I can force it to beep. Keeping it pressed, it will beep several times and will trigger the smoke action. Works perfectly. Now a short test simulating low battery voltage using the power supply. Works as well. Nice. Still we need to check if it's also working mounted on a ceiling. Let's try it.